All right, welcome back to eCruz Learning because it's just that easy with your host, Mr. Cruz. And today we're going to learn how to factor special cases. These are the easiest factoring things ever. If you see a special case, please identify. The first thing that we're going to learn is how to identify special cases, and this is going to help you master those skills, master the skill of factoring difference of squares 1, factor difference of squares 2, and 3. So those are three different skills in Khan Academy that you will be able to you'll be able to solve and to master. It's just factoring the special cases, and it will help you to factor some of the other quadratic functions because it has some special cases in them. So this is going to be ready quickly because these are special cases. We're going to use a white background today just for fun. Okay, so the first thing that we want to do is to factor perfect trinomials. So this is a perfect, okay, this is a perfect square. Okay, it's a perfect square trinomial. Perfect square trinomial. Okay, and I'm gonna give you some things that how this looks like. Okay, so here we go. The general form of a perfect, well, let me define this. A perfect square trinomial is a trinomial that is the square of a binomial. What the heck? Well, you know that a trinomial has three terms and a binomial has two terms. So this is what this really means in the general form: a squared plus 2ab plus b squared, okay, plus b squared, that just equals a plus b squared, okay, a plus b squared. And this will be very similar to minus. If this was minus, okay, if that was minus, then this is the same expression. It's just that instead of a plus b, you have a minus b. So those are the perfect squares things. So let's do example 1. Now, again, this assumes that you watch how to factor trinomials, okay, how to factor quadratic equations. There were two videos already on factoring, so this assumes that you've watched them both. If I say something and you have no idea what I'm saying, it's because you need to go back and watch those videos. Hopefully you watched them both already, and this is a special case. Okay, this is a special case. So here we go. This is the first special case. We have x squared plus 10x, and x squared plus 10x plus 25. All right, you have x squared plus 10x plus 25. You know how to factor this. Anytime that you factor a trinomial, you just open two binomials. You open two binomials. Because this is just x squared, you know that, well, let me just leave it there. Because you know this is x squared, this will be x, and this will be x, okay? Then we look at this right here, and because this is a plus sign, that just means that yes, we can. That means that these two signs are going to be the same signs. Which sign? Which sign is this? Yes, we can use the one in the middle. So then this will going to be plus and plus. Okay, that plus in front of the 25. Sorry, I did something crazy here. That plus in the front of the 25 just means that the signs are going to be the same signs, okay? And then you look at the sign in the middle to figure it out what it is, and it's plus and plus. Now we're looking for multiples of 25 that when you add them gives you 10, and that is not that hard because 5 times 5 is 25. So then this will be 5, and this will be 5. But check this out. And if you can foil this, and if you foil it back, okay, you're going to get the same polynomial again, because 5 times x is 5x. I'm just going to do this to make sure you're on the same page. And then x times 5 outer, that is 5x. And then 5x plus 5x is just 10x, which is the one in the middle. And you're done. You know that you're correct, okay? But we're not quite done yet, because check this out. We can simplify this. This is why this is a special case, because this term, this binomial, is the same thing as this binomial. They're both the same. So we can rewrite this as x plus 5 all squared. All squared. That will be the simplified version. And that is my answer. Now, there are a few things that I want you to see here, because this is the first time that I did it. But once you see this, everything is going to be so simple. Check this out. Do you realize, note that this right here, okay, this right here is the square term of this right here. Okay, that is the square term because x squared, if you take the square root of x squared, is just x. Okay, also the square root of 25. What is the square root of 25? The square root of 25 is 5 right here. 5, that's the square root of 25. So if you take the square root of the first term and put it on the beginning, and you take the square root of the last term and put it at the end, you put it in binomials and you square it, you get the answer. Okay, you can always double check it, or you can almost double check it because then 5 times 2 is 10. And that's where this comes from. Okay, that's where that comes from. If you take these two numbers and you multiply times 2, which is 5, is the same number, so you will get 2. Anyways, that was just a thought. Now, as we do this, is going to be easier. Okay, so I'm going to change to black background because I kind of don't like white background. I don't know if you agree with me or not. But here we go. All right, let's go to the next one. Let's go to the next one. The first one that I did was example 1A. Let's do example 1B. Example 1B says that 4x squared minus 24x, okay, minus 24x plus 36. Now we have to do this. We have to factor this trinomial, okay? Are we going to factor this? You know how to factor things. First of all, the first thing I want to point out is that this is a perfect square. Do you see that the number 4 is a perfect square? Because 2 times 2 is 4. Also, the number 36 is a perfect square. Because 6 times 6 is 36. It's going to be really easy, okay? We're going to open two parentheses. Okay, open two parentheses. And what is the square root? What is the square root of 4x squared? Well, it's 4x. So this is going to be 4x. Let me use this. And this is going to be 4x. Also, here we go. Well, now we look at the last sign. The last sign is positive. That means these two signs are going to be the same signs. And because we need to use the sign in the middle, if that's positive, then what we're going to do is that we're going to use minus sign. So minus and minus. We're almost done. Now we're going to double check. What is the square root of 36? It will be 6. Okay, so 6 and 6. Now I want you to notice, you could start listing here like the oh my goodness, the multiples, and you have 1 times 36, and you're going to have 2 times 18, and you're going to have 3 times 12, 6 times 6, I'm missing one, I believe 4 times 9, okay, and you might have the others, I don't know, I think that's it, but hey, you don't have to do that anymore, because this is a special case. If you're able to identify that the first term is a square term, and the last term is also a square term, then only thing you have to do is do this. Open two parentheses. Well, actually open one parentheses. What's the square root of the first one is 4x. What's the square root of the second one is 6. And then this has to be positive. This has to be positive. If that sign is not positive, this will not work. Because they both have to be the same sign to be the same binomial. Okay, they're both minus. It's going to be minus. And it's going to be squared because it's the same term, 4x minus 6. That's it. That is your answer. If you want to double check this, all you have to do is take 4 times 6 and multiply times 2. 4 times 6 is 12. And if you multiply that times 2, that's going to be 24x. That's the original one, 24x. So then you're done. That is your answer. So let's do one more problem like this. Try to do this because now it's your turn. Okay, now it's your turn. So the challenge that I want to give to you is that you have the answer before I finish writing the answer. Okay, so you have 64x squared minus 16x plus 1. Okay, plus 1. My challenge to you is, if you want to pause the video, pause it, all right, and then write out an answer, and then play it again. But this is not that bad. If you look at the first term, this is a square term. And the last one is also a square term. That's a perfect square. 1 times 1 is 1. So here we go. We open up one parenthesis this time. We know that this is going to be a squared. And then what's the square root of the first term? The square root of the first term is 8. The square root of 64 is 8. And the square root of x squared is just x. Okay, and then you have the square root of the last term. What's the square root of 1? Is 1. Now we have to look at the sign in the middle. Remember, this always has to be positive. If that is not positive, you cannot have a perfect binomial, a perfect trinomial. Okay, it has to be a positive so that they're both the same. Now the one in the middle, it's negative. That means my sign is going to be negative. That's it. That's my answer. Again, you can write this 8x minus 1 times 8x minus 1, and then FOIL, and if you FOIL, you should get back the original problem. All right, that's it. Now there's another type of special cases. Okay, and these are the ones that are very important because you will see them everywhere. When I told you everywhere, is that you're gonna find these everywhere. These are very, 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 very important. All right, and these are difference of squares. These are difference of squares. Now there's a key. There's something key in the name of difference of squares. Okay, and I'm gonna write right now the general form is a squared minus b squared, and that equals this. That equals a plus b, okay, times a minus b. This is a special case. Now, because it's called difference of squares, I want to make sure and emphasize as much as I can. Bold, underline, bold it, star it, box it, all right? Do whatever you want to do to the word difference, because this has to be minus. That right there has to be a minus, because that we're talking about the difference. A squared plus b squared is not a special case. A squared minus b squared, that is a special case. Okay, so here we go, because we have some special cases, and we're going to do example 2. All right, so let's do example 2a. I'm going to start off with something simple that should make sense. Okay, I'm going to start with something simple that should make sense. So here we go. Let's say that we have something like x squared minus 9. That is our example A, is x squared minus 9. If we have x squared minus 9, according to our special case, all we do is that we open two parentheses. Every single time that we're going to factor binomials, we open two parentheses. One it's plus and the other one it's minus. So one it's plus and the other one it's minus. And now, are you ready? If you don't see it, you miss it, okay? What is the square root of x squared? It's just x. So this is x and this is x. What is the square root of 9? Well, 9 is a perfect square and it's 3, because 3 times 3 is 9, so this is 3 and this is 3. That's it. We're done. Literally, we're done. We're done because that's a perfect square. Done. All right, done deal. Let's do another example so that it makes sense. Example B. Example B, we have that 25x squared. Okay, 25x squared minus 49. Remember, this only works. Well, it doesn't only work, but most of the time it just works if you have perfect squares. Okay, and we have something like this. We open two parentheses. We open two parentheses. Okay, open two parentheses, and then you're gonna have a plus and a minus. That it's automatic. Okay, plus and minus. What is the square root of the first term? The square root of the first term here is 25x squared. So this is just 5x. Okay, I hope you agree with me, because the square root of 25 is 5, and the square root of x squared is x. So 5x, same thing on both. And then what is the square root, again I'm color coding this, of 49 is 7. So this is 7 and this is 7. Done. That is factor. You see how fast that was? Let's do number C. I'm excited. I don't know if you're excited. Try to get this before I do, because this is easy. This is just that easy. All right. You look at this. Now, so example A and example B, extremely easy. Then you look at example C, and you go like, wait a minute. This doesn't have a perfect square. 125 is not a perfect square, and 45 is definitely not a perfect square. So what happened? Well, what happened is that now you have to start putting together everything that you know about factoring. What things do you know about factoring? Well, you could actually factor out a number. You could factor out a number, and this will equal which multiple of 45, it's also a multiple of 125. You're probably thinking about it, and yes, you're right, it's 5. We could factor out a 5. If I actually factor out a 5, Then I will open parentheses, okay? And you remember when you factor, all you do is that you take this term and you divide by the number you just factored by. So 125 divided by 5, that is just 75, okay? Hold on. Not 75. What the heck? I'm just checking if you are paying attention. This is just 25, all right? The x squared, I didn't factor any variables, so the x squared stays there. You could also think about this as quarters. How many quarters do I need to get $1.25? For 25, I'm sorry. If you divide by 5, yes, how many quarters do you need to get $1.25? 5 quarters, okay? So 125 divided by 5 is 25, and then there's a minus sign, so minus sign, and then 45 divided by 5 is just 9. Now if you look, now you have perfect squares. I could rewrite this as, and then open parentheses, what is the square root of 25? Is 5. So this is 5x, this is 5x. We know the signs. The signs are plus and minus, and then the square root of 9, we already did this earlier, that is just 3. So that's it. This is my factor form. If you look at this, everything is being multiplied, because remember, factor means that you're expressing something as a multiplication. It started as a subtraction right here, do you see that? But it ended as a multiplication, okay? It ended as a multiplication. Let me give you two more examples. For example 2, I want to do example D. What about if I give you x plus 9? What about if I give you x plus 9? Well, somebody who's really excited about this might say, okay, this equals, open parentheses, x, this is a plus, this is a minus, and then they will write down the 3. They're on the 3 and be like, hey, done. But be careful. Be careful, this is not true. This is not true. And I'll show you why. If you actually FOIL this, x times x, okay, x times x is x squared. Then x times negative 3, that is minus 3x. And then 3x times x, that is positive 3x, okay? Positive 3x. And then 3 times negative 3, that is just minus 9. If I combine this like terms, like we did at the beginning where we're multiplying polynomials, these two terms will cancel because that's negative 3x plus 3x, that's just 0. These cancel, and you end up with x squared minus 9. This is what I made a huge deal about this sign, because this sign is positive, is negative, is not positive. And I'm sorry, I just put x plus 9, so just because it was not a square term, you should have assumed that I cannot do this. But you have x squared plus 9, so yes, that's it. This is not the same thing because of this plus sign, and this is called difference of squares, not addition or sums of squares. So it only works when you're subtracting. I want to give you one more example, just in case they throw a curveball to you. Let's say that they say, hey, what about if I give you this? What about if I give you x minus 16? Could you factor that? And the answer is yes. Even though this is not a square term, all we've been doing is taking the square root of that term. So this equals, if you open two parentheses, one is going to be plus, one is going to be minus. And we always take the square root. So what is the square root of x? Well, the square root of x is that. The square root of x and the square root of x. What is the square root of 16? It's 4. So this is 4 and this is 4. Done deal. This is your answer. You just express that as a multiple of oh my goodness, it's a perfect square. It's a difference of squares. You express it as a multiplication, so that is a difference of squares. Okay, so that's it. That is all in difference of squares. You might get it backwards. You might get 16 minus x. Okay, you might get 60 minus x. That's the same thing backwards. This would just be, again, plus or minus. Square root of the first one is 4. Square root of the second one is the square root of x. Square root of x, and that's it. So that's all in special cases. I hope you enjoyed. There's two types of factoring that we're going to learn, but that was all for me. Factoring difference of squares and factoring perfect square trinomials. This was Mr. Cruz, and it's just that easy.